Hello. This is an introduction to Quartus. We're going to do an example of an xor-gate. So now, firstly, we have to start a new project. We're going to decide where we're going to put the project. So just create a new folder and put it in wherever you like on the computer. Now, we're going to name the top entity. So the top entity name is quite important because you have to reference it in your program. So just don't misspell it. Okay, we're going next, and then we just have to fill in the board's name. We're using the Atlas 5OC. Each board has its own code, and the code is usually in the middle chip engraved there, so you can even check on the board. This is the board I'm going to use. And then you have to simulate. We are going to use Model Sim Ultra, so just sit there and set next. Now, we have to start a new HTML file, so we're going to New, and we're going to select VHDL file and then say okay. Now we have a new file and we want to use a library IEEE. That's the one you always use. Then we say use IEEE.stdlogic1164.all. That's library part of IEEE you're all going to use. Then we're going to declare an entity. The entity needs the same name as the top entity you declared in the beginning. So you have to name it xor-gate. I'm just going to save it for now, and now I'm going to name it xor-gate. Then I'm going to say entity xor-gate is, and then you can declare what the entity is. So we're going to declare it as a So we're going to declare the ports of the entity. That's the inputs and outputs. So we're going to have two inputs as a in A, and then we're going to use a in B. So it's both inputs, and then we're going to have an output that is, I think I'll name it out lamp maybe, because it's going to put on a lamp on or off. That's basically all. Then you have to declare in for the input and then stg logic to say that's the logic type we're going to use. Do it with both inputs, and then the output we need to say out and then stg logic. So basically the same that we did with the input. So nothing new there. Okay, and then we have to end the entity. So you just have to type in XOR so that he knows, well, XOR gate. Now we're going to start the architecture. And the architecture name that you choose now doesn't really matter. It doesn't do anything to the program, but I'm just going for argument's sake with data flow, and then we're going to say of XOR gate is, because it is the architecture of actually the XOR gate. That's the inputs and outputs it's going to use. And then we're going to say begin, because we want to begin the architecture and then create a process so that we can actually program something. So basically the process, you have brackets, and inside the brackets you declare which input sheet is going to use. So this process is going to use basically both inputs that we declared. So we're going to say input A and then comma separate it with input B. Then we just say start process. Then we're going to do an if statement because we want to build the XOR gate. And the XOR gate is only on when both of the nodes are not the same. So we're going to have an if statement where if the input A and B are the same number, it's going to output a 0, else it will output a 1. So I'm going to do it the long way by declaring each type of state it can go into, and then later on I will refine it just by giving it the smallest amount of programming. So you say output lamp, and then we're going to say smaller than equal. The smaller than equals, like saying set it to 0. Now I'm just going to control copy and do it the easy way because I don't want to type this out the entire time. So basically I'm just changing the inputs and outputs, and now if they're not the same, they output to 1, else they don't output to 1. Then we just end, and we intended to let it look more pretty, and then we're going to end the process, and afterwards we're going to end the architecture. But for my example's sake, I'm going to use the wrong name, compile it, and then we will see the error appearing. and the error in red, yes, and it will say which line 25, and later on it will say it expects the name data flow. So basically it shows you what mistake you made and how to correct it. Now mostly it shows the correction, but sometimes it only says the line where the mistake is. So we're just going to type in data flow, and then we're going to compile it again. Then we will see that it compiled successfully, and now we can actually do the pin assignment. The pin assignment is basically the board, which input comes from what pin, like the switches and the lights. You can get the pin assignment on the internet. I'm just going to use it because this was not a tutorial on how to do the pin assignment. This was the introduction to Quartus. We can later on go into that detail. Now we just have to close this and then compile it again to actually compile the pin assignment. Now that it's finished compiling, we can actually go to program. Program is open, then we delete whatever is there because it's wrong. Then you press auto detect. If your board is in, the auto detect would work. Now I don't have it, and then afterwards you add file. You'll go to output file, and then you will see that's your xor-gate you programmed, and then you enter it, and then you press start, and then it will program the board, and then you're quite finished. So now let's go back to the program and edit it. So with the inputs, we can comma separate it and put the inputs in one line. And then basically with the if statement, we're going to use or because it gives the same output. So we don't have to have two if and else if. So we can delete that entire line. And now, because it is off when those two are true, we can input an else. So basically it will give you output of 1 if the above mentioned isn't true. So there, the program is finished and looks much more better than it did before. And the pin assignment is still the same, and now you can just delete this and add the new file that you have just saved, and then program the board, and it would still work. Well, I hope this would help you with Quartus, and have a nice day.